Now let's look at reciprocal quadratic functions. Quadratic meaning, of course, it has to have that nice little x squared up there. That's really quite important. Okay, so let's take a look at a simple thing here. A simple thing here is, remember this x squared minus 9, which is a nice parabola. And if you remember correctly, that is the y-intercept. So let's go. Y, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we wanted to find the x-intercepts, right, we let this parabola equal to x squared minus 9 equal to 0. So bringing the 9 over, you got x squared equals to 9, and then square rooting both sides, you've got x equals to plus or minus 3. So 1, 2, 3, and 1, 2, 3. There's your two, of course, zeros or whatever you want to call them. So it comes down like that and goes up something like that. Beautiful. Now, what does the reciprocal look like? Well, as soon as you reciprocate this, something really, really cool happens. Take a look at this for a second. What happens is you've got 1 over x squared minus 9. So guess what? Non-permissible values again. But the neat thing is you've already solved the denominator over here. So guess what the non-permissible values are? Those things that made this equal to 0. Ha! Well, so when solving it here, gives you the non-permissible values in the reciprocal. Beautiful. So x cannot equal to plus or minus 3. So right at plus 3, 1, 2, 3, we're going to put our, guess what? Yep, our asymptote. And at minus 3, 1, 2, 3, here's our other asymptote. Now, it's really strange the way this thing looks now. I'm going to draw it out for you, and then I'm going to show it to you on the calculator. The way it looks is really cool. It does this. It comes up, gets close to our asymptote, but never touches. This one on this side starts way up here and gets close to our asymptote, but never touches. So we've got actually a vertical asymptote at the non-permissible values, this point and this point, okay? And we have horizontal asymptote, of course, which is our line here. But what about this section in the middle? What about this in here? Well, the way it looks is really, really cool. Remember, you had a vertex here of minus 9. Don't forget, you're doing the reciprocal, which means flip it. So now you got minus 1/9. This value stays the same. So on the 0, you go to minus 1/9, which is about here. And that's going to be your vertex of your reciprocal function. And yeah, it looks very much like a parabola right here. Isn't that cool? So you get minus 1/9 right here, and that comes directly from this reciprocal right here. Okay, those two match, and you get these other two nice little bends here and here. And that's the basis of all of these reciprocal functions. So let's start looking at something a little bit more complicated. Let's look at this question here. So again, if you look at this particular question, what you got here now is you've got this beautiful parabola right here that we have to, guess what? Find the non-permissible values for, okay, because it's going to say graph the reciprocal of this. So this is 1 over whatever the f of x was. So first thing you want to do, go out and factor that. Yes, good old reliable PSA, you betcha. Look at this, never fails you. 10 minus 7, so this is minus 5 and minus 2, because the two of them add up to minus 7 and multiply together to give you positive 10. So your values are minus 5 and minus 2. So x minus 5 are your factors. X minus 2 are your factors. We let them equal to 0. X equals to 5. X equals to 2. So when we do the reciprocal function, guess what? X cannot equal to 5 and cannot equal to 2. There's your non-permissible value. So here we go. Let's make this graph a little bit bigger so we can play around with it. There we go. Okay, here we go. 1, 2, there it is. And so that's one of your asymptotes right there. And 3, 4, 5. There's your other asymptote right there. And basically, now all you have to do is realize, well, wait a second. What was my y-intercept? My y-intercept is when x equaled to 0. So guess what? That's gone. That's gone. My y-intercept was 10. So if we were graphing this normally, the parabola would be way the heck up here at 10. But now look, the interesting thing here is that it's got to be reciprocated, okay? So when it's reciprocated, yep, it's down here at the 10th. Beautiful. So what are you going to get? You're going to get a line that goes like this. You're going to get another line that goes like this. And you're going to get this wonderful reciprocal that goes here. That's how you do it. That simple. So let's look at our next one. Here I'm going to do something different. I'm going to take the exact same thing now, but look, our original parabola, because of that value, is now opening down. Okay, so you have to remember that the same thing I taught you before is if it was a positive value, positive parabola, it opens upwards. If it's a negative parabola, it opens downwards, and we call this a reflection. It's a reflection on the x-axis. Okay, so the way I designed this problem, if we go out and PSA this, you will actually, when you factor it, because remember now, you have a number up front that is not just 1 anymore, it's negative 1. You have to bring these two together, giving you a positive 10 and a sum here of 7. Add these together, that's going to be 5 times 2, 5 plus 2, value is 5 and 2, but remember, that value has to replace the middle guy. Okay, so when you factor this thing out, what you'll eventually get is something that looks like this. Now, I'm digressing from what the point is, but I want you to realize that when you factor this out, you're going to get a value here of x minus 2, x minus 5. That's how it works. Actually, it's going to be minus a plus. Apologize for that. Okay, it's going to look an awful lot like this. So what eventually happens here is this. Your x is going to still equal to 2. Your x is still going to equal to 5. But when you're doing the reciprocal, right here, the reciprocal, remember, these become non-permissible values. And these become your asymptotes. So still at 2, 3, 4, 5, and still at 5, those are your asymptotes. But remember what the graph did look like before. The graph before did this, right? And did this right here, right? Do you remember that? Okay. But now, because you have a negative up front, you have to reflect the whole thing. So we're going to reflect this line. This one here. It's no longer going to be there. It's going to be down here. Reflected. This line is no longer here. It is reflected here. Okay? And this line is no longer here. Okay? It's reflected here. That's the key. So let's get rid of all of the things that were in blue here that are no longer a part of this. Okay? Let's get rid of it. There we go. Get rid of this garbage. There we go. And get rid of this garbage. So you see that this guy is actually the reciprocal, or what I like to call, not the reciprocal, sorry, the reflection of what the original one was because of the negative that was up front there.